In this video, we will finish our analysis of this circuit by superposition by focusing on the version of the circuit where the 4 amp current source is highlighted and the 20 volt voltage source is ignored. In this version of the circuit, we have 3 meshes. I will write them as follows. Observe that they are not all clockwise. This one is clockwise, but these two are counterclockwise. I chose this one to be counterclockwise because it matches the direction of this branch and is actually 4 amps. That's just literally what it is, but I'll call it I1. Observe that it has to be 4 amps because for part of the loop, it's only in this wire, and therefore that the loop's current must be the current that passes only through this wire, which is 4 amps as forced by the current source. The current that passes through this branch is not necessarily 4 amps, it could be some combination of this current and this current. Anyway, we'll call this one I2 and we'll call this one I3. Maybe I should make these green. Let there be green. Just like before, let's start assigning voltage terminals and names. Behold, all of my terminals. Both I2 and I3 contribute positively to V1, so that's just 1 times I2 plus I3. V2 is just 2I2. The drop across V3 has a positive contribution from I2 and a negative contribution from I1, so V3 equals 3I2 minus I1. V4 has a positive contribution from I3 only, so V4 is equal to 4I3. V5 has a positive contribution from both I3 and I1, so V5 equals 5 times I3 plus I1. Now let's write the mesh Kirchhoff's law for I2 and I3. In I2, we have a rise of 5 I naught minus V1 minus V3 minus V2. For I3, we have a rise of 5 I naught, and then we have a drop of V1, and then we have a drop of V5, and then we have a drop of V4. And of course, these both equal 0. Let's give ourselves an expression for I naught. Take a moment to think and determine if you can get an expression for I naught in terms of I2, I3, and or I1. Pause now. I naught equals the combination of I3 and I1. Now, because I1 is 4 amps, let's convert all of these I1s into 4. All done. Now we can start plugging things in. For I2, the following substitutions apply. This equation is simplified as follows. For I3, the following substitutions apply, leaving us with this equation, which I'll convert to having positives. I've adjusted this equation by dividing everything by 2 and moving 32 to the right to get this equation with negative 16 to negative 3c. Then I can solve this system simply by multiplying this whole equation by 3 and adding it to this equation to get 17I3 equals negative 16, which implies that I3 equals negative 16 over 17. Because I naught equals I3 plus 4, I naught equals 4 minus 16 over 17, which is equal to 68 over 17, crazy, I know, minus 16 over 17, which is 52 over 17. Observe that I naught in this version of the circuit is negative 60 over 17. Observe that I naught in the other version of the circuit is 52 over 17. If we want to get I naught in the total circuit, we need only add those two values for I naught together. We discover that I naught is negative 8 over 17 amps. Turns out our direction for I naught was wrong all along, but it's the direction for I naught they wanted from us. Also, interestingly, that reverses the direction of this dependent current source, which causes more current to be directed in this direction, so it might make sense why current ends up getting drawn upward. Anyway, dependent current sources are weird, but the point is, we have I naught now. We are done. Hurrah, huzzah! We could probably have done this just by using one singular mesh analysis. I would suggest you do that as practice for yourself of mesh analysis.